Alright, so in our last video we talked about classes and inheritance. In this new video I'm going to be teaching about abstract classes and interfaces and what are the differences between these things and how do we use them in Java. Because these are very Java concepts. These are not general to all programming languages or object-oriented programming languages, even though many of them are using it as well. In Java, we have language support that helps us. In Java, we have language support that helps us organize how we have our hierarchy of classes. So, what is an abstract class? In Java, it's basically a class that cannot be instantiated. It means I cannot create objects for this class. And these classes serve as a base for creating other classes. They are usually abstract concepts that I want to generalize. So to create an abstract class, I just put the abstract keyword in front of the class, and that is how I declare an abstract class. And methods of the class can be abstract. When I have an abstract method, that means that that method is not implemented, because what I want is that every child class will implement it on its own. I know I want to be able to do certain things with these objects, but I don't know exactly how. And usually, abstract classes are the product of refactoring, because I'm working with a class and I start to figure out that maybe I can generalize some concepts and have some child classes to inherit from this abstract concept. So let's take a look at a class that is a bird class, and let's see how we can refactor it so that we replace the many conditionals of this class with abstract classes. Okay, so here I have the bird class. This bird class is quite big now, and it has a lot of attributes. It has the bird type, the weight, the number of coconuts, is nailed, voltage. It has a constructor. It has a method to get the speed of the bird, and then I have some other methods to calculate the base speed. And what I can notice right away is that the speed of this bird depends on the type of bird that we're talking about. So this is usually an indicator that there's something that we can generalize here. Maybe I want to get the speed of any bird, but the way in which the speed is calculated is different for each kind of bird. You see, for the European bird, it's like this, for the African bird, it's like this, and for the Norwegian blue, it's like this. So what do I do in these cases? What I can do is maybe I can create child classes that will represent these types of birds. And I can make this method in particular be a method that is not implemented by the parent class, but is going to be implemented by the child classes. So how do I refactor this? I can create, let's say I will create 3 new classes. I'm going to say European bird. I'm going to say a new class called African bird, and I'm going to create a Norwegian bluebird. Okay, these birds will extend the bird class. So this extends bird class. and this one extends bird class. So now I have my bird class, and I'm going to make it abstract. So I'm going to say that this is an abstract class. And I will identify the things that are common to any bird. So the getBaseSpeed method that is used by the European class is used by the African class, and I think the Norwegian blue also uses it inside this method. You see? So I think this is something, the getBaseSpeed is something that is common to all three classes. So I will keep this something here, for example. Now, this method in particular is not used by all of them. It's only used by the Norwegian blue. So I'm going to move this method inside here. And we'll worry about the private and all that afterwards. So I moved the method in the class that it belonged. Now I can do the same with the attributes. Let's see which attributes are used by the different classes. So European uses base speed, which uses weight. So weight is used by all of them, that's for sure. Then we have African. African uses number of coconuts and weight. So, and it seems like, yeah, this is the only class that uses number of coconuts. So I'm going to move this one into the African bird one. Okay, so I moved number of coconuts into the African bird. Now, is nailed and voltage is used only by the Norwegian blue. So again, I'm going to move these two attributes inside here. So now what I'm going to do is I'm going to create a method getSpeed in each class. I'm going to comment this. You'll see why. But I'm going to say public abstract double getSpeed. And this is how I declare an abstract method. So you see, this method doesn't have a body. I just put a semicolon at the end of the method. And this means that this method will have to be implemented by the child classes. It's not an option. They have to implement it. So now that we have removed the unwanted fields as well, I'm going to remove from the constructor the fields that are not common. And now we are getting there. So this is used by everyone, and this is going to be the new method that everyone will have to implement. Okay, so we have a lot of warnings here. So the first thing we have to do is create a constructor. Let's start with the European one, which is, I think, the simpler. So let's create a constructor for this. It's going to be public European bird, and it's going to have the weight, I think it's double weight, and it's going to have the bird type as well. We will avoid the bird type, and you'll see why. So bird type and weight. Okay. And is there anything else that the European one needs other than the weight? I think it doesn't. So European seems to be simple enough. So we're going to say super and weight, and the first parameter, which is type, we can basically hard-code it because this is always going to be European. And then there is another warning here. Let's see what it says. It says class European bird must either be declared abstract or implement the method getSpeed. You see, because this class has inherited from the bird class, it has to implement the method or be abstract so that its child can implement the method. But we want to implement it, so I'm going to say implement. You see, and here we are implementing the method getSpeed. So we have override here. This means that we are rewriting a method, and we are basically overriding the method getSpeed for the European one. So how can we implement this? So it's basically return getBaseSpeed, because now I know I'm dealing with an European bird. I don't need to do a switch. I can basically say just whatever the European speed was. And in here I have a problem because this method is private. It's an internal method and it's not accessible to the child. So how can I make this accessible to its child? I can make this method protected. So now this method is not accessible to other classes, but it's accessible to child classes. So you see now I don't have an error here. Now everything works fine. Now we'll do the same with the African bird. So we'll say public African bird, and we'll receive the weight, double weight, and double number of coconuts. And we'll have to say super, and this is going to be type African, and the weight, and now we have to initialize the number of coconuts. So this number of coconuts equals to number of coconuts. And again, I have a warning here saying implement the method. So I'm going to implement it by saying public double get speed, and I'm going to put the annotation override so that this checks that the signature of the method is exactly the same, and then I can see how it was implemented in the bird class. So it's basically base speed minus load factor number of coconuts. So I'm going to copy this here, and I don't have the load factor because it's in the upper class. So I'm going to, because it's not used in other places, I'm going to remove it from here. And I'm going to put it in the African bird. So we always want to hide as much as possible. So this will not be accessible to other birds. It's only accessible to African birds now, because we're hiding how an African bird works. And finally, let's see the Norwegian blue. So the Norwegian blue one, I have to implement the constructor, public Norwegian blue bird, and it's going to receive the weight. It's going to receive boolean is nailed, and it's going to receive double voltage. So super, the type will be Norwegian blue, weight, this is for the bird attributes, and now for the Norwegian blue attributes, is nailed equals to is nailed, and this dot voltage equals to voltage. And now everything is fine. Now I'm lacking the method that I need to implement from the abstract class. So get speed. And how was the implementation for this? Let's look at it in the bird class. Implementation is this. So let's put this here. So let's see. Now, what else are we missing? Let's remove this because now we have done the refactoring. And you can see this class is now way smaller. And we have these 3 classes that hide how different types of bird work. So how do we run this? So I'm going to create a main method here. And let's say I want to create a new, let's say I want to create a list of birds. So I will create a new array list. I'm going to say list bird birds equals to new array list. And I'm going to be adding new birds to this list. And you notice I'm using the abstract class. And I said I cannot create objects of this class. And that is true in a sense, but I actually can by using its childs. So I can say, for example, new, let's say new European bird. And the weight is going to be, I don't know, 100. And I can make this a European bird, a type European bird, and that is fine. And I can also make it a bird, because it is a bird. So even though I cannot instantiate a bird, I can instantiate a European bird, which is a bird. So in some sense I can, but I cannot do this, for example. I cannot do new bird. Let's say we have the weight, it would be the type European and 100, for example. This is throwing a compilation issue because bird is abstract and cannot be instantiated. You see? I'm going to declare another bird which is African, new African bird. And let's say the weight is 80 and the number of coconuts is 3. And then the last will be a Norwegian blue. And this is going to be, actually I'm going to use the same values for all of them so that we can see the differences. So I'm going to use 100 as the base, but we'll see the differences. And voltage is, I don't know, 220. Let's say 20. And now I'm going to add these birds to a list. So the list here, birds, add. And I can say European bird, add. I can add the African bird. And I can add the Norwegian blue bird. And I'm going to add a new method here just to get the type of the bird. So let's make it, let's create a getter for type. Now I have this method, bird type. Now I can see the type of the bird. And now I'm going to create a for loop. And I'm going to say for bird a bird in birds, and I'm going to print the type of bird is, and I'm going to say here a bird dot get type plus the speed is, and the number of the speed, so a bird get speed. So you see, I can use the method get speed because it's a birds method, but this method doesn't have any implementation here because it's implemented by its child classes. So we'll see different values, and we'll see how, depending on the class, it will do different things. And so let's run this. Awesome. So you see, now we have the type of bird is European, the speed is 1. The type of bird is African, the speed is minus 25. I don't know how we got negative, so it's going the other way around. It's going the other way. And then this one, the type of bird is Norwegian blue, and it has 20 as a speed. So this is awesome. So we have different types of birds, and this is what we're using here is a very, very important concept of object-oriented programming called polymorphism. Polymorphism is the ability to call methods of an object without knowing the concrete class of that object. So in this case, I'm using the bird class, which is an abstract class, and I don't know the base class in this case of this object. I cannot know it because I'm using bird. But I don't care about it because I know that birds have a method get speed. Each kind of bird will implement it on its own, and it will have its own implementation. But what I care about is that they are birds and they do have this method. So this is what we mean by polymorphism. We can have many forms of the same method, of the same behavior, and this is a very, very cool concept that is used a lot in object-oriented programming. You will see in the video I'm doing on lists and maps and all that you can also see polymorphism there with those lists. Okay, so let's talk about interfaces now. In object-oriented programming, the interface of a class is everything that can be accessed from the outside. For example, the public methods and the public members of the class. If the class has public fields, that is also part of the interface. That is a general concept. It's not the Java version of interface. In Java, the interface is actually supported in the language as a keyword. So you can create something that is an interface, and an interface declares a list of methods that we want our classes to implement. So you know how we did with the getSpeed method, which was an abstract method that we wanted the child classes to implement? Interfaces have the same, but they can only have these kind of methods. At least up until recently. Now interfaces can have other kinds of methods, but we'll talk about that in the future. But for the most part, interfaces are used to declare a list of methods that we want classes to implement. And the thing is, interfaces allow for multiple inheritance. So instead of classes where you can only inherit from a single class, even if this class is an abstract class, you can inherit from only one class. Interfaces allow you to inherit from multiple interfaces. So you can have one class that implements multiple interfaces. And implements is the keyword in Java to tell that this class is implementing an interface. And interfaces can also inherit from other interfaces. So you could have a hierarchy of interfaces. And in the case of interface inheritance, we do use the word extends. So for example, list is an interface that extends from a collection interface. So there is an interface called collection, there is an interface called list, and list extends collection. But then you have a class called ArrayList, and this ArrayList implements list. That means that it implements methods from both list and collection. Right, so let's create a new interface here. I'm going to create a new interface called moving entity, okay? And I am going to add a method here, which is going to be void, and let's just call it move, okay? And this method will be implemented by the classes that implement this interface. So now I'm going to add this interface to this class. Implements moving entity. Okay? And I'm going to also add it to the person. So person implements moving entity. Okay? So now you'll see what happens. So in the case of the bird, because the bird is an abstract class, I don't need to implement this method right here, but I will have to implement it in its child classes. So if I go here, it will tell me, please implement methods. And it tells me the move method. You see? So I'm going to implement it, and I'm going to say sort, and I'm going to say flying with coconuts. Now I'm going to go to the European bird, and again I have to implement the method. So I'm going to say override public void move. And in this case, I'm going to say just flying then in the case of the Norwegian blue, I'm going to say flying with electricity. I don't know why. And then I have to implement it for person. So person is not an abstract class, so it has to implement it, because I can instantiate a person that is not an employee. So I'll have to implement this, and I have to say move, and I'll say sort just walking. But in the case of an employee, I want to, even though I don't need to override this method, because you see I don't get any warnings, because I can simply use the method in person, I want to override this. I'll override it. So I'll say override and public void move. And this is a method that comes all the way back from person, and from person goes to moving entity. So I'm going to say suit and walking with suitcase. And now what I can do is I'm going to remove all this, and I'll start to create many objects from the employee class, from the bird class. So let's just copy from the bird class all this. And I'm going to have, let's say, another list of moving entity. So moving entities, new array list. And then I'm going to add also, let's first add all the birds, and you'll see we can do this because the birds are moving entities. So I can say add all, and I can add this list of birds to the moving entities list. And then I can say moving entities dot add, and then I can say new person, and let's just copy a person from here. Let's just copy a person from here. So I'm going to copy this person here, and I'm going to add an employee as well. And in this case, it's going to be named Mary Smith. She was born the same day. Her position is CEO, and her date of incorporation will be now minus 3 minus years 3, so 3 years ago. So now I will have a for loop of moving entities. So moving entity in moving entities, and I'm going to call moving entity dot move, and we'll see all the different implementations of this, and this is going to be excellent. I'm running this. You see? So the bird is flying. The European bird is the first one. It's flying, then flying with coconuts, then flying with electricity, then just walking, the person, and the employee is walking with a suitcase. So this is what we can accomplish with interfaces. And we can add multiple interfaces. So we could have another interface, which is, for example, we could create a new interface in here, and we can call it sleeping entity, for example. And it's an interface. And we can create a method sleep. So if I make the person, for example, I can make it implement sleeping entity. I import this, and now I have to implement the method sleep. You see? So I'm sleeping. So basically, you can have as many interfaces as you want in a class. And this is the difference between interfaces and abstract classes. Also, in the abstract class example with the bird, we had the bird also has some members of the class. It has fields, but interfaces cannot have fields. They can only have constants and they can only have constants and abstract methods. Also, interfaces at some point they couldn't have implemented methods. So interfaces in the old days couldn't have implemented methods, but since Java 8 now they can have implemented methods. But that used to be a difference between interfaces and abstract classes as well, because abstract classes you could have these kind of methods that are implemented, and then there were other methods that were abstract. In interfaces, all methods were abstract. So if you see the interface that we created, we didn't put abstract, but because it is an interface, it is abstract. And it doesn't have a body, you can see. Now, since Java 8, we can create methods here. So we could say, for example, default, and we could say moving by default. And this is a different kind of method. So void, I had to put the return type. And moving along. So this kind of method is a method that will be inherited by everyone in the hierarchy. It's not that common to use this. We mostly use interfaces for these methods. We don't want the default methods. Almost never we use the default methods, but they're useful at some point, and they were really useful when they implemented some functionality in Java 8. So, but yeah, the main differences between interfaces and abstract classes is that interfaces allow for multiple inheritance, abstract classes don't. Interfaces have abstract methods. Abstract classes have abstract methods, and it can have also regular methods. Any of them cannot be instantiated. You cannot instantiate an interface, and you cannot instantiate a abstract class. And abstract classes can have fields. Interfaces cannot have fields. So if you remember these things, then there is a lot that you have already understood about object-oriented programming. Alright guys, so we talked about interfaces and abstract classes, and this concept can get actually really abstract. So I would encourage you to look for more tutorials about this, to see, do exercises, see where you can refactor things into abstract classes, and keep practicing. This is a matter of practicing and getting comfortable with all these concepts. If you like this video, please subscribe to the channel, comment, and like the video. And I'll see you in the next episode. Bye!